Welcome to the video for C6.1.11 corrosion. So before we start, if you're watching the interactive version of this, there should be 5 quiz questions just about to pop up on your screen, so have a go at those just to have a look at what we can recap from previous lessons. If you're not watching the interactive version, then just let the video play. So our learning objectives for today are firstly to describe what corrosion is, and secondly to describe the conditions needed for corrosion. So there's 2 pictures here. So the Statue of Liberty, if you've presumably seen pictures and movies of it, it looks like it on the right. So we're used to seeing it as this kind of green colour. But the picture on the left shows what it would have looked like when it was first made. So it was this beautiful copper colour because it's made of pure copper. So I'm just going to want you to pause the video here and think about why you think it's changed from the picture on the left to the picture on the right. Okay, so hopefully you've come up with some idea about reactivity. So the word we need to use here is corrosion. So the lesson title was a bit of a hint. So the Statue of Liberty originally just had that copper, but over time the copper has reacted with the oxygen in the air to give copper oxide, and copper oxide is that green coating that you can see. So we're going to look at this today. So we need to know the definition of corrosion. So corrosion is where a metal reacts with chemicals in its surroundings, and it's normally the oxygen in the air or the water vapor, or just water droplets indeed. Sometimes it can be like acid rain can cause corrosion, so it might be some acid in the water droplets that can also cause corrosion. Now, corrosion is more likely if the metal is more reactive. Hopefully this makes sense. So you should remember seeing a reactivity series, and the reactivity series, if you look at the top of it, they're the most reactive metal. So something like potassium, sodium, calcium, they're going to corrode really quite quickly. If you look at something in the middle, so something like iron corrodes reasonably slowly. So if you think about things rusting, if you leave like a bike outside that's got a steel frame, then it's going to rust quite slowly. It's not an instant thing. If you look at the bottom, so platinum and gold don't really corrode. They're so unreactive that they don't really react with the oxygen, which is one of the reasons that we use platinum and gold in jewellery, because then your jewellery stays nice and shiny and doesn't corrode. So I've talked about rusting. People quite often get confused between corrosion and rusting and use the 2 terms interchangeably. We need to be careful. So corrosion is a general term. So it's a reaction of any metal with chemicals in its surroundings. Rusting is a specific example of corrosion. So it's only for iron or steel. So steel is an alloy that contains iron. So rusting is for the element iron, but because steel contains that element, it also rusts. Now you need to know the word equation for rusting. So it's iron plus oxygen plus water to give hydrated iron oxide. So it needs both oxygen and water for this reaction to occur. And as shown on the slide, hydrated iron oxide is what we call rust. So when we see that orange kind of flaky substance, that's our hydrated iron oxide. So if we were in a classroom right now, what we would normally do in this lesson is we'd do a rusting experiment. So we'd take some nails and we'd put them in various different conditions, and then we'd leave them for a week and we'd see how much rust has got. So you can see from those 2 nails, the one on the left-hand side has got less rust, and the one on the right-hand side has got more rust. So the typical conditions that we wouldn't get rust, so if there's no water, so if we just put a nail in a test tube with no water and just let it be exposed to the air, then you wouldn't get very much rust. There is some water vapor in there, so you might get a little bit if you left it for a long period, but it's not going to be very, very much. If you wanted to see the effect of just oxygen but no water vapor, then you could put some anhydrous calcium chloride in there. That would absorb. So anhydrous just means without water. The anhydrous calcium chloride would absorb the water vapor from the air, and then you could see that if you just left it with just the oxygen and no water, that you wouldn't see any rust at all. If you wanted to see the effect of water without oxygen, then if you boil water, it gets rid of any dissolved oxygen. And therefore, if you boil water and put it in a test tube and just place the nail in that and seal the top of it so no more air can get in, then you could see the effect of that. And if it's just water with no oxygen, then you shouldn't see any rust, or a very small amount. On the right hand side is a more rusty nail. So if you've got both water and oxygen, so if you just got a nail and put it in with water and you left it open so there was air as well, then the oxygen from the air and the water are going to combine to give that hydrated iron oxide, so you're going to get more rust. The one that normally looks most rusty is if we add salt as well as water and oxygen. The salt acts as a catalyst and speeds the reaction up, so you see lots of rust. Right, here's some key questions that you now need to answer in your class notes. So either write it in your one class note or write it on a piece of paper and upload a photo. So the questions you need to answer are: what is corrosion? What's the difference between corrosion and rusting? And also write a word equation for rusting. The last thing you need to do if you're watching the interactive version of this video, is answer the quiz questions, which are just about to come up. If you're not watching the interactive version, then you need to log on to Office 365 and you can answer the quiz questions that way. Okay, thank you for listening. See you next time.